Hello students, we are discussing the chapter indefinite integration and the very important type integration by substitution. Let us see one example important from entrance point of view also. It says evaluate the integral sine 2x upon a sine square x plus b cos square x with respect to x, therefore a dx. The first step, copying the question, naming it as I. Now what are we supposed to do in this sum? That we will come to an answer only when we observe some small things here. You have to observe, you have to note that the derivative of sine square x is nothing but sine 2x. How is that? Because derivative of sine square x is 2 sine x into cos x, which is nothing but sine 2x. Likewise, derivative of cos square x, my students, is minus 2 sine x cos x or minus sine 2x. Okay? Now, if you observe, students, that what we have, derivative of sine square and cos square is sine 2x, which is my numerator. So we can say that the derivative of the terms in the denominator is present in the numerator. Is that okay? That gives us a leverage of substitution. So we can very confidently write, let a sine square x plus b cos square x is equal to nothing but t. After writing this, I am sure you know the next step, that is differentiating with respect to x. We already have seen the derivatives. So what will be the derivative? The derivative of sine square x will be sine 2x and that of cos square x will be minus of sine 2x. So we get a sine 2x minus b sine 2x into dx is equal to dt. Can we say sine 2x is common? So we can say in the next step sine 2x into a minus b dx is equal to dt. That means, can I say sine 2x dx can be written as dt upon a minus b? Is that okay, students? So derivative is done, adjustment is also done. Let us resubstitute these things in the integral. What was my integral? Here it is for your reference. This was the integral we were supposed to evaluate. So if we were to evaluate this, can I say in place of a cos square x plus b sine square x, can I write a t? And in place of sine 2x dx, can I write dt upon a minus b? Is that okay, students? Now a minus b is a constant. So can I take it outside the integral? So we have 1 upon a minus b. What is left inside the integral is 1 by t dt. Now students, I am not writing the formula of integral 1 by t because I am very confident you already know it. Integral of 1 by t dt is log mod of t plus c. Now we cannot keep the answer in terms of t. So let us resubstitute. Let us put the value of t, that is nothing but a sine square x plus b cos square x and plus c has to follow. Now students, you may remember this as a formula for sums where we will have to solve in entrance. Is that okay? Let us take one example from the entrance part of it. Now this is a question in front of me. It says integral of tan x upon 9 tan square x plus 4 dx. Now if I were to tell you this sum is based on the earlier sum we solved, you may not be convinced because this question is in terms of tan x, whereas the earlier sum was in terms of sine and cos. My dear students, you observe the options also. Every option is in terms of sine square and cos square. So you should understand that the very first thing we should do is convert tan to sine by cos. So the first thing we'll write here is integral of, instead of tan x now we'll write sine x by cos x. Instead of tan square we'll write sine square by cos square and plus 4 has to follow. After doing all this, it is obvious to me that the next step should be LCM. Again from the options it is clear. Every option has 4 cos square. So if I take LCM, the numerator will become sine x into cos x and the denominator will become 9 sine square x plus 4 cos square x. Correct? Now students, the shortcut we studied or we were supposed to remember had sine 2x in the numerator. So can I multiply divide by 2 here? Perfect. And what did we achieve in this? So I can write in the next step 1 by 2 integral sine 2x dx upon 9 sine square plus 4 cos square x. Is that okay, students? Now let us recall something. This is what we just saw some time back. Okay, just for your reference I marked it important also. Okay, now students, compare the integral in that particular formula and the integral here with me. Can I say they are in the same form? Now if you observe that the value of a required, here it is 9. And can I say now value of b is 4. So if I have to get the answer, it has to be 1 upon a minus b. So 1 upon a minus b means 1 upon 9 minus 4, which is 1 by 5. So my answer will start with 1 by 2 into 1 by 5 log of the answer. In the formula you can check, my students, it has log of. Log of what? Log of denominator, which is very well seen in option B. So my correct answer will be option B in this case. Okay. Now for your reference, you may solve these sums as practice. That's all we have in this module. Thank you very much.